Okay, we're going to do some algebra vocabulary that you're going to hear all year long, and then we're going to do a little bit of practice with simplifying expressions. So let's just fill in these boxes to start off with. We've got the top box that's pointing to all of the X's. When you have letters that are representing unknown quantities, those are called variables. They don't have to be X. It can be any letter. Sometimes you'll even see symbols like Greek letters and things like that. Now let's look at the 2 and the 5, and then do you see that divided by 3 thing? I need to show you something that you need to revise on this. And I'm going to do the vocabulary term first, and then we'll talk about how we can deal with that divided by 3. These numbers are called coefficients. And coefficients are numbers multiplied by a variable. So 2 is a coefficient because it's 2 times x, and 5 is a coefficient because it's 5 times x. We don't want to say that the coefficient for that last term right there is 3. We need to figure out what number is being multiplied by the x. And here's what you need to remember. Dividing by 3 is the same thing as multiplying by 1/3. So we can say that the coefficient of that x term is 1/3. Or another way to look at it is if you have a variable by itself. So if you have an m by itself, the coefficient on that m, if nothing is showing, is automatically a 1. If you have a t and there's no coefficient showing, it's automatically a 1. So if you look at just this portion right here, and there was originally no number being multiplied by the x, then automatically it's a 1. So coefficients, you're going to hear me say coefficient very often, so keep in mind that that's what they look like. And then that last box on the right is pointing to the +4 and the -12. Notice those are not variables, they never change. That -12 is always going to be a -12. Its value stays constant, and that is the name for that kind of a term. So just plain numbers. So keep in mind here, as soon as that plain number is multiplied by a variable, we now call it a coefficient. Okay, so let's talk about the portions of this, or the parts of that equation that we see above. I want you to notice that the 2 parts that we're looking at right here are the left side of the equal sign and the right side of the equal sign. Notice there's no equal sign. If we just pull out the left side, it's just 2x plus 4, and just the right side, and that's 5x plus x minus 12. Those are called expressions. And an expression is just a math phrase. Just like you have a phrase in a sentence, it's not a complete sentence, it's a part of a sentence. Expressions are a part of an equation. There are 2 vocabulary terms that you'll hear associated with expressions. Expressions can be either simplified or evaluated. So, and there are 2 ways that you can simplify expressions. We're going to talk about evaluated in another video, but there are 2 ways you can simplify expressions, and one is by using distribution, and the other is by combining like terms. And we're going to do that later on in this video. Now, as soon as we take 2 expressions and we set them equal to each other with an equal sign, now we're talking about an equation, and equations are math sentences. So if you're dealing with a part of an equation, I'm going to talk about the expression on the left side of the equal sign and the expression on the right side of the equal sign. And then the whole thing I'm going to call an equation. Now, the vocabulary term associated with equations is that equations can be solved. So in other words, we can figure out what value of x makes this expression equal this expression. That's called solving. We could not solve 2x plus 4. We could not solve 5x plus x minus 12. We can only simplify those or evaluate those. So we're going to go on to what does it look like to simplify expressions. So we talked about 2 different ways to simplify expressions. One is called distribution, or you can distribute, and the other one is called combining like terms. So there's a specific time that you distribute, and it's when you multiply a constant times a sum or difference of terms you're going to distribute. So let's look at situations that would be distribution and some that are not distribution. So let's do this. So let's look at 2x plus 3. The first criteria is that you're multiplying. And right here, we are multiplying that too. The second, so are we multiplying? We're going to say yes. The second criteria is that we're dealing with multiplying times a sum or difference of more than one term. Notice it's a sum, and that sum separates terms. This is term 1, and this is term 2. So we are dealing with a sum of more than one term. So that's yes. And so yes, we must distribute. So what does that look like to distribute? Well, think about the word distribute in normal, just everyday language. If you distribute papers to a class, that means you give a paper to each individual student. When we distribute in math, we take the number that's being multiplied times the sum or difference, and we make sure we multiply it times every term in the sum or difference. So now we're going to do 2 times x plus 2 times 3. Or in other words, 2x plus 2 times 3 is 6. And that's what distribution looks like. Now let's look at the second example. So first we want to say, are we multiplying a constant? And we're not. We're actually adding a constant here. So we can automatically say that we are not fulfilling that first criteria of multiplying. Now we do see a sum of more than one term. So that's a yes for this column of, is it a sum or difference of two terms? Or of more than one term, excuse me, but it has to fit both criteria for us to be able to use distribution. So I'm going to talk to you about how we would simplify that at the end, but I don't want you to put it in this table. So we're just going to put NA, because although we can do something with this expression, we're not going to be distributing. So let's look at the next example. So first, we are multiplying a constant. So we can say yes for this first column. However, we are not multiplying it times a sum or difference of terms. This is actually only one term. So since we're not dealing with a sum or difference of more than one term, then we will not be distributing. And again, I'm going to say NA for that. And then finally, -3 times the quantity 5 minus x. First, are we multiplying a constant? We are. We're multiplying a -3 times. So we can say yes for are we multiplying a constant. And then in the parentheses, we have here a difference of one term, two terms. So a difference of more than one term. So we can say yes here. Yes, we will distribute. And so let's do that. So we've got a -3 times 5 minus x. So we're going to multiply -3 times 5 and -3 times, and I would look at that as a negative x. So here we're going to do -3 times 5, or you could say minus -3 times x. And in that case, my parentheses are only separators. They're not a grouping symbol. Or we could just look at it as a -3 times 5 and then a -3 times negative x. So either way is going to get you the same answer at the end. So a -3 times 5 is a -15. And then I'm going to go ahead and do it like this. I'm going to bring down the minus sign, and then -3 times x is -3x. So that ends up being a -15 minus a negative is the same thing as a plus, so we get 3x. Now, here's the deal. I'm showing extensive work here, but you probably don't need to do that. So I always just think, okay, -3 times +5 is -15, and then I think -3 times negative x is +3x. So hopefully one of those two kind of perspectives made sense to you. All right, the other way that we're going to simplify expressions is by what's called combining like terms. Combining like terms is another way of saying that we're adding or subtracting. So combining in this case is talking about adding or subtracting. Now let's talk about like terms. The way that I think is the best to help understand the concept is that like terms have the same shape and size. So if combining like terms or identifying like terms is kind of a tough thing for you to wrap your head around, think about terms like a geometric shape. So I've drawn 3 geometric shapes over here, and let's just name them by their areas. So if you look at that little square at the top, hopefully it seems reasonable that I could say that the side lengths of that square are 1. So 1 times 1 means that this has an area of 1 square unit, and we're going to call this a unit. These are going to represent constants. So if I wanted to represent 3 in shapes, I could just draw 3 little squares. So let's look at that next shape. Notice the side length here is the same as this, so we can say that that's 1. Now, we don't know the length of this side length, so what we're going to do is assign it a variable. So we're going to call it x. Now, the area of that shape would be 1 times x, so this is going to be called an x. Now, if I wanted to represent, here, let me write the 3 right here. Now, if I wanted to represent, let's say, 2x, I could draw that as 2 of those kind of rod shapes. And finally, if you notice, this length right here is the same as this length right here. So this is an x by x. What's the area of that shape? It would be an x squared. So if I wanted to represent, for example, a 2x squared, or let's say a 4x squared, then I could draw 4 big squares. And if you keep kind of this model in your head, and I ask you if it would make sense if I combined all of these together, would it make sense to say that we have 6 x's? Hopefully it doesn't, because you know that this is an x squared. So the only thing we can say is that we have 4x squared right here, and then 2x right here, and 3 units right there. And we can't combine those different shapes and sizes. They have to stay separate. So like terms have the same shape and the same size. Now let's translate that into kind of like the formal math way to express that. You can only combine terms with the same variable and exponent parts or combination. So let's do some examples of that. So if we were to say 2x and 3x, and I'm going to ask, are those two terms like terms? Well, think about their shapes. The 2x would be like this, and the 3x would be like this. They have the same shape and size. So if we lump those all together, we could just say that we have 5 x's. So are these like terms? Yes, they are like terms. So now let's do some different operations using those two like terms. So we've already done the first one. If I do 2x plus 3x, that gives me a 5x. If I do 2x minus 3x, we're going to say it's negative x or negative 1x. No need to put the 1, but that's what the plain variable means. Or if we did 3x minus 2x, we would say that that is a positive x or a positive 1x. So let's go on to another example. Let's talk about 5x and 5x squared. Notice they do have something in common. They have common coefficients. Are they like terms? Well, think about their shapes. A 5x, each of the x's would look like that, but an x squared, they would all look like that. Can we put those together? No, we cannot. So these are not like terms. So this is a no. And let's look at what those operations look like. 5x plus 5x squared is 5x plus 5x squared. You could just say it's already simplified. 5x minus 5x squared, again, it's already simplified. We can't do anything to make that simpler than it already is. Or 5x squared minus 5x, it's already simplified. Because those two terms are not like terms, you cannot combine them. Okay, let's look at this last one. So we've got a negative 7n squared m and a 5mn squared. So they look a little weird. They don't automatically look like terms, but the order of the variables doesn't matter. So if you notice, the n is squared for that first term, and the n is also squared for the second term. The m is basically to the first power for the first term, and also to the first power for the second term. So you're not often going to see terms written out of alphabetical order, but every once in a while you will, and you just need to remember that the order doesn't matter. What matters is that you have the same variable and exponent combination. So are these like terms? Yes, they are. So let's combine them. So negative 7n squared m plus 5m squared mn squared is going to give us a negative 2mn squared. I'll put it in alphabetical order. Now what if we subtracted it? Negative 7n squared plus or m minus 5mn squared. They're both negative, so they're going to work together. So it's going to be a negative 12mn squared. And the last one, 5mn squared minus negative. Remember, minus and negative is the same thing as plus. So 5 plus 7 gives us a 12mn squared. Okay, I want you to notice for the two examples that had like terms. So this example right here and this example right here. Notice the variable part didn't change. It started off with x and it ended up with x. It didn't change to like x squared or anything like that. All you're doing is you have 2 of those rod shapes and you're given 3 more of those rod shapes. So now you have 5 of those rod shapes. So same with this one. We don't necessarily have a shape for an mn squared, but if you could imagine a specific shape for that, notice if you have 7 negatives and 5 positives, the negative and positive ones are going to cancel each other out, and then we'll have negative 2 left. So recognize this. The variable part does not change. The only thing that you actually do the addition and subtraction on is the coefficient. So only change the coefficients. Okay, now here's the deal. Usually you see combining like terms first and then distribution just because it seems like it's that way in textbooks. But I purposely put distribution on the left and combining like terms on the right. Why did I do that? Well, I want you to think about the operation with distribution. Distribution is multiplication. Whereas we already talked about combining like terms is adding and subtracting. So which one do you do first? If you have both, if you could simplify both ways, you always do this first if you can. So let's do some examples. So first example is here. So first you want to look and see if there's anything to distribute. And the fact that we don't have any parentheses anywhere kind of is a good indication that we don't have anything to distribute. But we do have some like terms. So I suggest having some way to note the like terms. So if you have different colors, maybe color code them. I'm going to draw probably boxes and circles, and you can do that as well. These are our 2 like terms. So we can combine those. So 2x minus 6x is going to be a negative 4x. So now let's go ahead and simplify the rest. Normally, you're going to see the term that has the biggest exponent first, and then it'll go down from there. So let's rewrite this expression as 4x squared The next highest exponent term is the minus 4x, and then finally we can put the plus 5, and this is fully simplified. Let's do the next one. So first thing you always want to check for when simplifying expressions is, can you distribute? Right here we're multiplying a constant times a sum of more than one term, so we can distribute the 5. So 5 times x is 5x, and 5 times positive 4 is positive 20. So I'm going to rewrite the rest. We've distributed, so now let's look for like terms. So here we have an x term, but we don't have any other x terms. Here we have a positive 20, it's a constant, and we also have a negative 2, that's a constant. And finally, we have a negative 3x squared and a positive x squared, or positive 1x squared. So let's do highest exponent or highest degree to lowest. We're going to do a negative 3x squared plus 1x squared, so that's going to give us a negative 2x squared. So now I've dealt with that one. A lot of times to keep myself organized, I will mark them out. The next one is the x term. Because there's no sign, it's automatically a positive. So we're going to say plus 5x, and now 20 minus 2 gives us 18, and we have this expression fully simplified. Okay, next question. Let's look and see if we can distribute, and we can. We can distribute in two different places. We can distribute the negative 7 to the m and the minus 1, and we can distribute 3 to the m squared and the minus 6. So let's do that first one. Negative 7 times m is negative 7m. Negative 7 times negative 1 is positive 7. The next part, 3 times m squared, it's a positive 3 times m squared, so 3m squared, and a positive 3 times negative 6 is a negative 18. Now that we've distributed, we can look for like terms, and we only have one set of like terms. Let me just note this. Make sure when you're identifying like terms that the sign to the left of the term you're looking at stays with it. You don't want to make an arithmetic error because you've accidentally dropped a negative. So let's go ahead and we're going to do from highest degree to lowest. So this one's our highest degree, so we're going to put 3m squared. We cannot combine an m and an m squared. Think about it. An m might be like a rod shape, but an m squared would be a big square. So then the next one is minus 7m. And then we can go ahead and do 7 minus 18, and that gives us a negative 11. And now we're fully simplified. And finally, kind of a messy one. Normally you're going to see x's and y's and things like that in Algebra 1, but definitely want you to be comfortable if you see other letters or variables. So let's look for distribution. Here we're going to distribute. Be careful. You are distributing a negative. So make sure you multiply by a negative. So let's go ahead and write what we've got for the next line. We're going to do a negative 2 times b squared. So negative 2b squared, and then a negative 2 times negative a is positive 2a, and then a minus 3a, and then a plus 5a squared b. Okay, now let's look for like terms. So right here, it's an a to the first power b squared, and over here, it looks deceptively similar, but it's not exact. So those two are not like terms. But we do have one set of like terms, and that's this, the positive 2a and the minus 3a. So let's go ahead and write down what we have. I would start with the 5a squared b, and then do the 4ab squared, but I'm not going to be like picky about these. Just get it simplified and don't worry quite so much about the order. I'm going to go ahead and mark those two out, and now let's do the minus 2b squared, and then 2a minus 3a is going to be a negative a or a negative 1a, and now our expression is fully simplified. Okay, the last thing I want to do is I want to talk about, well, how would you do these two questions? So let's do that. So the first one, I'm not going to put it in that table because I don't want you to think that that's distribution. 5 times x plus 3. Or 5 plus x plus 3. So in this case, like even though this the parentheses are acting like a grouping symbol, these are not like terms, so you can't combine them. So we can just look at it like 5 plus x plus 3, and there's no distribution happening, but we can combine the two constants together and say that this is x plus 8. And then that other one was 7 times 3x. The error that students sometimes make on this is they do 7 times 3 and 7 times x. That is not the case. We do not distribute unless there's a sum or a difference in the parentheses. So all we're doing here is doing 7 times 3, which is 21x. Or think about it as we have 3 x's, and we're going to duplicate that 7 times. Well, you're going to end up with 21 total x's. So again, not distribution, but definitely something you could simplify.